Okay, we are starting the third part of our SQL 50 LEETCODE challenge series. So far we have done select and basic joins. Now we are moving a basic aggregate function. The first question is 620 called not boring movies. So we have been given a table named cinema with 4 different columns, and we have to write a solution to report the movies with odd numbered ID and descriptions that's not boring. We have to return the result table ordered by rating in descending order. So we have example here. So there's basically 2 conditions. The ID number should be odd, and the second condition, the description shouldn't be equal to boring. So that's why we need to take 1, 3, and 5. But since the 3 is the description boring, we have to avoid it. So basically we have 5 and 1, and 5 comes on the top with the descending order based on the rating. So let's start with our select statement. Since we need to get all the columns in the output from original table cinema, so we will select all from our table name cinema. Then we have to filter our result to get the odd numbers. So to get the odd numbers, yes, there is the operator, like arithmetic operation, like modulo. We have like this. We also exist in Python. So basically, the result of the modulo operation gives us the remainder of the division, meaning that if it's the odd number 5 divided 2 gives us a remainder of 1, the same for the 7 or 9. So basically this will help us to filter the IDs and to get all these IDs with odd numbers. So it means that where ID, though it's as the same as the percentage sign, ID modulo is 2 divided like 2 will give us a remainder of 1. And our second condition is the description, which is not equal to the boring. So not equal, we use exclamation and the equal sign. Or you can also, I already explained in my earlier videos, you can also use smaller, bigger. This also means not equal. So exclamation and with equal sign, and since boring is a literal string, so we will use a single or double quotes equal to boring, and we need to order the result by descending order. So it means order by DESC by actually we need to put order by and then rating, then at the end we need to put DASC, stands for descending. Let's run it. Okay, and submit. Okay, we move to another question here. Average selling price, problem number 1251. So we have been given a table prices. So it has 4 different columns: product ID, start date, end date, and price. So each row of this table indicates the price of the product ID in the period from start date to an end date. So for each product ID, there will be no 2 overlapping periods. That means there will be no 2 intersecting periods for the same product ID. And we have also a table called units sold. Here we have product ID. Okay, this is the shared column between 2 tables, and we have purchase date and units. So we have to write a solution to find the average selling price for each product. So average price should be rounded to 2 decimal places. Okay, if a product doesn't have any solid units, its average selling price is assumed to be 0. Okay, that's interesting. So here, for example, we have product ID 1 Actually here we have, yes, the same product ID, but it has two different periods. One, it starts from February 17 till 28. It has a price of 5. The second period, we see that it's beginning of March until 22nd, and the price was different. And here units sold table gives us number of units that the product ID 1 sold in that purchase date. So that purchase date comes in this start and date. So basically meaning that the product was sold in a different price in different period. Okay, so for example, the 15 units was sold in the price of 20 because this is corresponding to that date, but 100 units was sold in the price of that one. So that means that the average selling price that we will calculate will be first getting the sum of all the units sold. So it means 100 multiplied with 5 plus 15 multiplied with 20, then divided the sum of the units sold. Okay, let's start. So we start with, okay, the select. So basically what we need to do, we need to use the left join because we want to get all the records from our left table, which is the prices and the corresponding product ID which exists in units sold. Then we need to also use for the average price. So basically we need to use the sum aggregate function to so sum of, okay, we will see it. Okay, first let's start. Select so product ID we will select from the price table, which will give a list of p dot product ID. Then okay, so basically we need to calculate the sum of so we need to multiply the price with the units. So it means p dot price multiplied with the units from the unit sold table. So we will give it shorter u dot units. Then we need to divide this, as you see here, total of the number of units sold. So basically sum again, sum of units, so units from the units table, so u dot units. Okay, then we need, okay, there is another condition. If the product doesn't have any sold units, so we should give it to 0. It's kind of a binary, 1 and 0. So what we will use is we have a function called if null. So if null, it's like if it's true, it's attributed to 1. If not, it's given to 0 value. So which means that we will add if null in the beginning of that. We open the brackets, parentheses, and then, okay, if it's 1, then another one is a 0. We close here, and then we need to round it to 2 decimal place. So again, we need to add another function called round in the beginning of the if null, and here we will round it. Okay, so basically comma 2, so it will round the final result to 2 decimal place. And we need to give our result a name of average price. Okay, let's copy paste average price. So this we will select from our left table, which is the prices. We call this a P. Then we use a left join with our second table, which is units sold, which we give as, then on keyword, So here we have, so this our joint condition. The first will be the product ID, because these are the repeated in both common shared column in both tables. So basically we will have a p dot product ID equal to u dot product ID. But the second condition, so we want to get the combination, the corresponding values of purchase date within the price table, which are in this range. So to avoid the rest, okay, because there's two different pricing and for the units sold in different purchase date. That's why we will use a keyword and to join our second condition, our joint condition. So here we will say, so the purchase date needs to be between this start and end date. So basically u dot purchase date, we will use a keyword which is called between p dot start date, comma p dot end date. So since we use the aggregation function in our select statement and we need to group all the result, we will use a group by function. So we will use a group by product ID. So p dot product ID. Let me check. Okay, in n order. Normally we can end our query here. Use a keyword here, start. Let's see. There is a problem here. First of all, p dot should be, it's here because I was looking for the field, but okay. So units sold, we gave it as a shorter alias u, so it should be u here. Okay, now it's perfectly running. Good.